Hey guys, this is Sundar from Svan Elastomers. Svan Elastomers is essentially a custom rubber compounding company. I started this company 12 years back and we've been quite successful in terms of positioning ourselves as a credible alternative to our customers to provide rubber compounds on an outsourced model. And when we say outsourced model, it does put a lot of responsibility on our company to provide adequate confidence and evidence to our customers that we are able to provide rubber compounds that work for them. Okay, and this we have to do on a repeatable basis and a consistent basis, on a batch to batch basis, so that the entire pursuit of my company is essentially to ensure that every batch that we produce, it is basically meeting our customers' requirements in terms of making it work for them. So there is one important aspect, a singular aspect, which helps me to bridge the gap from the rubber compounding process and the downstream molding process, and that is rheometer and rheology. Okay, so I just want to talk about it. What I feel that I have been able to do is that I have been able to internalize the concept of rheology, and I have been able to translate it into a language which is quite easy for my operator to understand, so that he is the person who is going to be the custodian and the guardian in terms of certifying that my compound is ready for my customers. So what am I going to talk about? I'm going to talk about three aspects or three dimensions. The first dimension is that of vulcanization, which is the heart of any rubber polymer industry. The second one is the molding, which my customers are essentially into. And the bridge between these two, that is vulcanization and molding, is the rheometry or rheology. Now let us go through each of these dimensions in a little more details. Okay, vulcanization. When we talk about vulcanization, I want to address vulcanization in terms of three questions: what is vulcanization? How vulcanization? How does it take place? And when vulcanization? When I say when, it is basically the time dimension. Okay, so let us talk about the what vulcanization. Vulcanization essentially is the chemistry of the bonding, where the polymer linkages happen either through sulfur bonds or peroxide bonds and various other chemical bonds, which provide the basic physical properties to the rubber compound, to the rubber component. So that is essentially the chemistry of the vulcanization process. That is the what. How does it happen? For basic vulcanization to happen, you need three things to come together. You need temperature, basically typically around 140 to 180 or 200 degrees. You need pressure, because you have to apply pressure to bring multiple layers of compound and metal together for the compounding, for the vulcanization to take place. And you need to provide time. So basically it is three things. It is pressure, temperature and time. Okay, this is the basic essence of vulcanization, how it takes place. There is another how part of it, which is the chemistry, which is essentially see, each of these topics I can keep drilling down and talk about it for a long time. That is not the intent. Essentially vulcanization, the how part, there is an activation, there is an acceleration and there is a bonding. So basically this is, I will leave it at that, and whoever is interested can deep dive into each of these layers of vulcanization. The third aspect is the when part, the timing. Time is a very essential part of vulcanization, because it tells you, how much time you have for loading the particular mold cavity, the compound into the cavity, and the flow to take place, and how much time you need to give for the curing to take place. And if you want to go into the technical aspects of it, there is something called reaction kinetics. That is a field of study in chemistry where you study the rate of the reaction. Okay, and there is first order reaction, second order reaction. So essentially the heart of the timing of vulcanization is governed by something called the Arrhenius equation or the chemical kinetics. I will just leave it at that, because whoever is curious can actually go into the details of it. Now let us look at molding. What is molding? Molding, or any downstream process, is basically to starting from a compound which is unvulcanized rubber. It has all the ingredients which makes it ready for vulcanization, but it is not yet started the vulcanization. Okay, so you need about 3 or 4 things for the molding process to happen. First is you need the compound which is weighed accurately, which will fill the complete cavity of the molded die. So the volume of the cavity plays a very important role in it. Okay. Then there is a flow. When we load the compound onto the die, the compound is at room temperature, typically maybe 25-30 degrees, depending on the ambient temperature. It is still not in the vulcanization temperature zone. But when we close the die, the first thing that happens is the flow, because you want a solid compound to fill every nook and corner of the cavity. So the flow of the compound into the cavities is a very essential part of the molding process. Okay. The third process is essentially that of removing the air entrapment, and the fourth one is essentially the giving the time and the pressure and the temperature for the vulcanization to start, so that at the end of the optimal curing cycle you get the molded product. So this is molding. Now, I told you in the beginning that I'm going to talk about rheology, which will link these two aspects. Okay, so why rheology is important to link these two? Because the rheology testing is done to a unvulcanized compound, which is vulcanizable. That means it is ready to be vulcanized, but it is not yet vulcanized. What do we do in a rheometer? We take a small sample, typically about 5-6 grams, very less. Okay, it's not too much. You take that sample, you measure it accurately, and you put it in a rheometer. The rheometer essentially is like the molding process itself. Okay, it is molding process, but you do it under standard test conditions. That means you control the pressure, you control the temperature, and you control the time. So it is molding under very tight controlled condition. Now, this is the interesting part which I want to talk to you about. How can we use rheology to get an insight about the performance of the compound? When we talk about a rheometer, there are about 6 or 7 key parameters, and I will just name that to you. Okay, there is ml, there is mh, there is ts2, there is tc10, there is tc90, then there is a trend, and there is tan delta. This is typically what you talk about when you talk about rheology. This probably captures bulk of the key parameters that you look for in a rheometer. The first aspect which I'd like to talk about, when I talk to my operators, what I tell them is, you please look at mh minus ml. Okay, that is a key parameter. Why is it important? mh minus ml is the difference between the highest torque and the lowest torque. And why is this important? Because it talks about the extent of cross-linking. Because you remember, we just want to check the extent of cross-linking, which is vulcanization. So I tell my operators, whenever you do your rheometer, please check mha minus ml. That's the first step. The second part, to link with the molding process, is when we do the molding, you want to give adequate time for the rubber compounds to flow into the cavities comfortably before the vulcanization can start. Okay. So how do you measure it? How do you get an estimate of how much time is required for the flow to happen? This is governed by the parameter called TS2. Okay. And there's another parameter called TC10. TS2 is an arbitrary number actually. It is basically 2 units plus the ml. ml means L is the lowest point. So the lowest Muni which is there on the rheometer plus 2 units is the TS2. And that time is universally accepted in the industry to be a reasonable indicator of the flow time. Then there is another parameter called TC10. And to me, TC10 is little more scientific than TS2. That is my personal opinion. And I'll tell you why. TC10 means the time required for 10% vulcanization to have happened. That is what the 10 means. Okay, 10%, how is it calculated? mh minus ml is the maximum torque difference, which talks about the total cross-linking which is possible. So that is 100%. So 10% of mh minus ml basically is 10% of cross-linking. And the typical expectation or empirical evidence is up to 10% of vulcanization, the compound still has the ability to flow into the nook and corner of a cavity. Okay, so TC10 is, in my opinion, a very good indicator to measure the flowability of a compound. Then we talk about TC90. which is called in industry parlance optimum cure time. Okay, because of the nature of the curve, it is almost impossible for any compound to get to 100. There's nothing like TC 100 because it takes infinite time. Okay, or actually after some time you get into reversion, which I will come to a little later. So TC 90 is considered to be the optimal cure time. So why is this important? When you talk about a production, the TC90 is the optimal cure time during production. Okay, and this is a measure of productivity. If you give too much time, you lose time and your production volume goes down. If you give less, the product is undercooked. So there is, you have to hit that magic number in terms of hitting the number which is close to TC90, which is the optimum cure time. The other parameter which we also look for in a rheometer is that of trend. There are three trends possible. One is called marching, one is called plateauing, and the other one is reversion. Marching means the curing is still happening at the time of the MH being reached. That means the curing is not yet complete. Okay, so that means that we have to give more time. That's what it means. When we end a rheometer test on marching basis, it means that we have not really tested it until the end of the logical end of the curing cycle. Plateau is the phase you want to end or terminate the rheometer. Okay, that is a good phase to end. But sometimes you deliberately want to extend the testing time to see whether there is a reversion. Reversion means going back in terms of vulcanization, which is also a very practical problem, because when you overcook something, that is also detrimental to the molded product. So you don't want reversion to happen as well. And sometimes you just want to find out how much time it takes for the reversion to get started. The last point is that of tan delta. This is little more technical, okay? Because you have to drill down to the next level of conceptual understanding, because there is, when you mold a particular product, there are two shear forces, that of viscous force or viscous elasticity and storage elasticity. This basically talks about how much of damping or how much the bounce back that a rubber can exhibit. And when you talk about rubber, bouncing back is one thing that it comes to everybody's thinking, saying that rubber has the ability to bounce back. So when you want to measure whether the rubber is a bouncing back kind of rubber or it has a damping kind of rubber, you look at tan delta. So this is a little more technical, but actually a rheometer can give very good insights about that aspect as well. Why is all this very, very important? Let me summarize. A rheometer curve is like a signature to a particular compound. Okay, for a good practitioner, you can just one glance at the rubber compound rheometer, it can tell you whether it's all right or not. This is akin to a cardiologist relying on an ECG and looking at those curves. He knows how the heart is performing. Okay, so the curve of the rheometer actually tells the entire story about how that compound is there. It also talks about consistency, because many of the rheometers which are available commercially today, you can do multiple tests on the single screen. And when you have the rheometer curves go one after the other on top of each other, okay, it means that there is a lot of consistency in the mixing process. So friends, in my experience, when I tell my operator to look at and to tell him what to look at, these are the things which I try to explain. I try to distill this entire thing down. My job as an entrepreneur and my job as a technocrat is to simplify even the most complex aspects so that my operator can understand and completely imbibe that concept. And he is the custodian of quality for my company. Okay. I cannot stand there and look at every batch. It is not feasible and it's not practical. And therefore, my value that I bring it is I bring those concepts, make it simple so that my operator can understand and he stands on my behalf and he becomes my custodian. So friends, whoever is involved in the lab, whoever wants to know about rheology, there is a whole new way of looking at rheometer, and you can look at the rheometer to see the entire aspect of rubber compounds. I hope this was very useful. I would love to have this as one of the series, and as and when there is an opportunity, I would love to come up with more and more such themes where I'm able to simplify even complex concepts and bring it to a language that anyone can understand. I hope this was useful. I look forward to interacting with you as in time an opportunity comes over. Thank you, friends, and thanks for your time. Bye.